Imagine a world where ancient artisans wielded the power of nanotechnology, crafting objects that defy explanation with techniques lost to time. This isn't the premise of a science fiction novel, it's the enigma surrounding the Lycurgus cup, a 4th century Roman glass artifact that has baffled historians, scientists, and archaeologists for centuries. Housed in the British Museum since 1958, this extraordinary chalice doesn't just captivate with its intricate design, it harbors a secret that hints at an astonishing level of technological sophistication in antiquity, blending artistry with a proto-scientific mastery that continues to intrigue us today. At first glance, the Lycurgus cup appears unremarkable, a finely crafted glass vessel standing about 16.5 centimeters tall, adorned with a carved scene depicting the myth of King Lycurgus entangled in vines, a punishment from the god Dionysus. But its true magic reveals itself under different lighting conditions. When viewed in natural or reflected light, the cup glows an opaque, mossy green. Shine a light through it, however, and it transforms into a translucent, radiant ruby red. This dichroic effect, where an object displays two distinct colors depending on the light, makes the Lycurgus cup a standout among ancient artifacts. But how did Roman craftsmen achieve this feat over 1,600 years ago, long before the advent of microscopes, or the concept of the nanoscale? The answer lies in the glass itself, or rather, in the infinitesimally small particles embedded within it. In the 1990s, researchers using electron microscopy and spectroscopy uncovered the cup's secret. Its glass is infused with nanoparticles of gold and silver, each measuring between 50 and 100 nanometers in diameter. For context, a nanometer is 1/1000th of a meter, and these particles are smaller than the wavelength of visible light. When light interacts with these metallic nanoparticles, it scatters in unique ways, producing the cup's mesmerizing color shift. This phenomenon, known as surface plasmon resonance, occurs when light excites electrons on the surface of the metal particles, causing them to oscillate and alter the light's reflection and transmission. The gold nanoparticles contribute to the red hue, while silver enhances the green, with the precise ratio, about 70 parts silver to 30 parts gold, fine-tuned to create the cup's dual color effect. Modern science recognizes this as a hallmark of nanotechnology, a field we associate with cutting-edge laboratories, not ancient workshops. The discovery suggests that the Romans, perhaps unwittingly, stumbled into a realm of material science that wouldn't be formally understood until the 20th century. The discovery raises a tantalizing question. Did Roman artisans intentionally harness nanotechnology, or was the Lycurgus cup a happy accident? Crafting such an object would have required extraordinary precision. The metals had to be ground into particles finer than dust, mixed into molten glass at exact concentrations, and cooled under controlled conditions to preserve the effect. A slight miscalculation, too much gold, too little silver, or uneven distribution, would ruin the dichroism. The complexity of this process hints at a level of experimentation that goes beyond mere chance. Some scholars argue this could have been a serendipitous byproduct of Roman glassmaking. Ancient recipes often included trace metals from ores or recycled materials, and alchemical experimentation was common. Gold and silver, prized for their luster, might have been added to glass for decorative purposes, inadvertently producing nanoparticles when heated and worked. Others, however, see evidence of intent. The Lycurgus cup is one of only a handful of surviving dichroic glass objects from antiquity, suggesting it was a rare and deliberate creation, possibly reserved for elite patrons or ceremonial use. Its uniqueness among thousands of Roman glass artifacts implies a specialized knowledge, perhaps guarded as a trade secret. The cup's mythological imagery offers another layer of intrigue. King Lycurgus, a figure from Greek lore, opposed Dionysus, the god of wine and revelry, only to meet a grim fate. The cup's red glow, when filled with liquid, perhaps wine, might symbolize blood or divine retribution, aligning its optical trickery with its narrative. Was this a clever fusion of art, science, and storytelling, designed to dazzle guests at a Roman banquet? The vessel's small size and elaborate craftsmanship suggest it was a luxury item, possibly used in rituals or as a status symbol among the Roman elite. Roman glassmakers were undeniably skilled, producing everything from delicate vessels to massive window panes. Texts like Pliny the Elder's Natural History describe their use of minerals and metals to color glass, copper for red, cobalt for blue, though no surviving record explicitly mentions nanoparticles. The Lycurgus cup suggests their knowledge may have extended beyond what was documented, bridging the gap between craft and proto-science. Archaeological evidence from Roman sites, such as furnaces and glassworking tools, supports their advanced capabilities, but the cup stands out as an anomaly, a leap into the nanoscale that defies easy explanation. The Lycurgus cup isn't entirely alone in hinting at ancient nanotechnology. Similar dichroic effects appear in other rare artifacts, like certain pieces of Roman glass jewelry and fragments from the Eastern Mediterranean. In the Middle Ages, stained glass windows in European cathedrals owed their vibrant reds and yellows to gold and silver nanoparticles, a technique likely inherited from earlier traditions. Even further back, ancient Egyptian and Mesopotamian craftsmen used metallic compounds to create lustrous glazes on pottery, though these effects were less dynamic than the cups. These examples suggest that the manipulation of tiny particles, whether intentional or accidental, may have been more widespread in antiquity than previously thought, forming a shadowy precursor to modern materials science. Today, the principles behind the Lycurgus cup inspire cutting-edge technology. Nanoparticles are used in medical diagnostics, detecting diseases by changing color in the presence of specific molecules, in solar cells to boost efficiency, and even in stain-resistant fabrics that repel water at the molecular level. In 2013, scientists at the University of Cambridge recreated the cup's effect using modern nanotechnology, confirming that tiny variations in particle size and shape dictate the colors produced. They went further, developing a prototype biosensor inspired by the cup, capable of detecting pathogens in liquids with a color shift visible to the naked eye. Their work underscores the artifact's significance. It's not just a relic, but a testament to human curiosity and ingenuity that transcends millennia. The cup's creation around 300 CE places it in the late Roman Empire, a time of transition marked by economic strain, political upheaval, and cultural exchange. Glassmaking had spread across the Mediterranean, with hubs in Italy, Egypt, and Syria, producing wares for a vast market. The incorporation of gold and silver, costly materials, hints at a patron of significant wealth, perhaps a senator, a merchant prince, or a temple. Its survival through centuries of turmoil, from the fall of Rome to its rediscovery in the modern era, adds to its mystique. How it remained intact while so many other treasures were lost or melted down is yet another puzzle. The Lycurgus cup remains a riddle wrapped in glass. Was it the work of a single genius, a secretive guild, or sheer luck? Without ancient blueprints, or a time machine, we may never know. Chemical analysis has revealed no obvious impurities or errors in its composition, deepening the mystery of its making. What's certain is that this small chalice challenges our assumptions about the past, hinting that the line between ancient craft and modern science might be thinner than we think. As we marvel at its shimmering hues, the Lycurgus cup invites us to reconsider the capabilities of those who came before us, masters of a nanotechnology we're only now beginning to understand, whose legacy glows as brightly as the cup itself. Thank you for watching. If you found this video insightful, don't forget to like, share, and subscribe for more content on ancient mysteries, spirituality, and self-development.